Hello friends, this video on solid states part 24 is brought to you by examfear.com. No more fear from exam. Let's understand magnetic properties. Have you ever wondered why some substance behaves like a magnet? They attract and they are used in the speakers mostly. You must have seen any speaker, then you'll see the black color magnet there. Why? Why magnet attracts only iron, not plastic? See, every substance has some magnetic properties, right? And origin of these properties lies in these electrons. If you see these electrons, they will tell you why they are magnetic. In fact, if you see each electrons, you see they are jumping around, they behave like a tiny magnet. So its magnetic moment, that is the magnetic moment of the electron, they originate from two types of motion. One is the orbital motion around the nucleus. If you see these electrons, they are moving around the nucleus. And the other is the spin around its own axis, right? They spin. Now, since these electrons, we know that they are charged, correct? So when charged electron or charged particle is moving, you can think this of as a small loop of current which possesses a magnetic moment, because you must have learned in physics that if the charged particle moves, it creates a magnetic moment, right? And since these electrons are charged and they move, so they create a magnetic moment. So each electron will have a permanent spin and the orbital magnetic moment. And magnitude of these moments are very, very small. And they are measured in a unit called Bohr magneton. BOHR. This is the unit, right? This is what it's called, and its value is 9.27 into 10 to the power minus 24. There are two units. One is ampere meter square, or you can say joule per Tesla. Yeah. So that is my Bohr magneton. That is the magnitude of magnetic moment of one electron. Very small, but if you club millions and millions of electrons, you get powerful magnet, correct? And there are different types of magnets. We have paramagnetic, diamagnetic, ferromagnetic, antiferromagnetic, and we have ferrimagnetic. So let's understand this now. The paramagnetic. See, in paramagnetic, these are weakly attracted by magnetic field. Let me write here. Weakly attracted by magnetic field. Very weakly attracted, right? Why they are attracted? Because they are magnetized in the electric field in the same direction, right? Or they are magnetized in the presence of electric field in the same direction. But the moment you lose this, the moment you remove the electric field, they lose their magnetism. So they lose their magnetism in the absence of electric field. And this property is because of presence of one or more unpaired electron. And these unpaired electrons are attracted by magnetic field. Example is oxygen, Cu2 plus. So if you see oxygen, if you draw the molecular orbital diagram, which if you want you can refer the atomic chapter where we have discussed about this, you see that it has unpaired electron, and that is the reason why it is paramagnetic. And if you see, this is a liquid oxygen and these are my magnets, and it is attracted by the magnet. This white color, if you see, is my liquid oxygen, correct? The next is diamagnetic. So diamagnetic substances are weakly repelled actually. Weakly repelled. So if you see, this is my magnet and this is floating because it is repelled. They are not attracted, they are repelled. They are just opposite of paramagnetic. right? Example can be water, my sodium chloride, or C6H6. These are examples of my dimagnetic. They are weakly magnetized again in the presence of magnetic field, but in the opposite direction. Correct? So they are again weakly magnetized in opposite direction, and that's why they repel. Correct? Here there is no unpaired electrons. All electrons are paired. So if you draw a molecular orbital diagram of this, you'll see that all the electrons are paired. There is no unpaired electron, right? And pairing of these electrons will cancel the magnetic moment, and thus they lose magnetic characteristic. The next is ferromagnetism. This ferromagnetic substance, if you see some of the substances like iron, cobalt, nickel, they are strongly attracted by magnetic field. So earlier one, paramagnetic and diamagnetic were weakly. This is strongly attracted, and this is strongly attracted by magnetic, right? So if you see, if you take this iron, any iron object near the magnet, you will see it will be attracted. This iron nail is attracted by this magnet, and these are called ferromagnetic substance. Correct? Ferro, actually word came from iron, because iron is a very strong ferromagnetic substance. And the good part is they can be permanently magnetized. They can be permanently magnetized. Okay. Now if you actually see this lattice of these ferromagnetic substance, you will see that these ferromagnetic substances are grouped together into small regions called domains. They have small regions called domains. And each domain acts as magnet. So it is like lot of small magnets forms a big magnet. Okay. So in a normal unmagnetized form, you'll see that these domains are randomly arranged. Correct? Right? Unmagnetized. In unmagnetized form, these domains are randomly arranged. Correct? Since these domains are randomly arranged in the unmagnetized form, they don't have a very strong magnetic property, because these moments generally cancel each other. But when you put this in a strong magnetic field, this ferromagnetic substance, what happens is these domains are all arranged in the magnetic direction. You see, right? They are all arranged in the same direction, and thus they become magnetic. And this order of this domain orientation will persist even if you remove the magnetic field, and thus it becomes a permanent magnet. Correct? So this order, this domain, these are all domains actually. So these domains orientation will remain same even if you remove the magnetic field, given you are applying a very, very strong magnetic field. So thus my ferromagnetic substance will become permanent magnet. Correct? So what are ferromagnetic substances? They are strongly attracted by magnets, and they can be permanently magnetized. What is the logic behind it? So in ferromagnetic substance, we have small regions called domains, and they act as a magnet. But in the unmagnetized form, these domains are randomly arranged. When you put a very, very strong magnetic field, these domains are properly arranged, and even if you remove the magnetic field, these domains are in the same position, and thus they become permanent magnet. The next is anti-ferromagnetism. If you see, the name suggests from ferro you have anti-ferromagnetism. So in this case, if you see some substance like MnO, they also have domain, right? They have domain, but this domain structure similar to my ferromagnetic substance, but these domains are oppositely oriented. Since these domains are oppositely oriented, they cancel each other, right? And generally, if you see, this anti-ferromagnetism is observed at low temperature. Correct. So they have domains. If you see here, they have domains, but this domain cancel each other. Correct. And that is my anti-ferromagnetism. The next is ferrimagnetism. The name ferri came from ferrites. Ferrites. What are ferrites? Nothing but iron with a +3 charge. Correct. Here we have domains. They are aligned in parallel and anti-parallel direction. But the number is unequal. If you see 1, 2, 3, 4. Sorry, 1, 2, 3, 4. Correct. 4 in the top direction, 2 in the bottom direction. So in that way, effectively it is magnetic, but it is weakly magnetic because you have 1, 2, 3, 4 and 2 in this direction. So 2 will cancel each other. Only 2 is remaining. So it is magnetic, but it is weakly magnetic. Correct. Example is Fe3O4. So it has domains, but they are also aligned in the parallel and anti-parallel direction. So, and that will be an unequal number. So the key terms are unequal number. Correct. And they can also be made paramagnetic actually. If you heat it and if you pass through a very strong magnetic field, you can make it a paramagnetic. The only thing is, right, you have to change the domain. So for that you need to heat it and pass it through a strong magnetic field, and all these will be aligned in the same direction and it will become a ferromagnetic. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.